In the 1980s, a customer in a Soviet retail store would likely pay with a clerk tallying up the sale on a wooden abacus. Meanwhile, across the ocean, a decentralized personal computing market was exploding, placing machines like the Apple II into homes and classrooms. Yet decades earlier, this exact same nation possessed the engineering capability to build the first capsules to carry humans into orbit. They successfully directed a massive military-industrial complex capable of guaranteeing nuclear parity with the United States. This creates a historical question. How did a nation with such immense engineering talent end up with a domestic tech sector that looked like a museum exhibit? To find the answer, we have to look at where their scientific journey actually began. After World War II, the foundations of Soviet computing were laid in an unlikely place, a bombed-out former monastery in the forests outside Kiev. Here, in 1951, a scientist named Sergei Lebedev directed the assembly of the MESM. It was the first stored program electronic computer in continental Europe. His team worked under severe material shortages. When they couldn't acquire the right components, they scavenged parts from abandoned German military equipment and wired up cheap oscilloscope tubes to serve as memory storage. This diagram illustrates the sophistication of their work. They didn't stop at basic calculators. These pioneers independently developed parallel processing, splitting calculations into multiple data streams that move simultaneously through separate nodes to solve massive equations. In the early 1950s, Soviet and Western scientists were operating on a similar footing, independently building the first generation of high-speed electronic tools. By the late 1960s, the global computing race was accelerating. Soviet leadership, facing strict state production quotas, demanded a shortcut. Instead of trusting their pioneers, government planners issued a mandate: clone the American IBM 360. This became a nightmare. Without blueprints, technicians had to piece together undocumented components. The decision sidelined the country's most visionary engineers. They were forced to abandon their original research to spend years trying to replicate an aging American machine. By the time the Soviet copies were finally in production, the American originals they were based on were already obsolete. Instead of forging ahead, the industry was now trapped in a cycle of chasing a moving target. A functional technology sector requires a consumer ecosystem to push it forward. In the Soviet-planned economy, there was no commercial market to demand faster or more user-friendly products. This side-by-side diagram shows the software divide. Soviet engineers prided themselves on complex, formal mathematical code, represented on the left, which was difficult to use. Meanwhile, Western commercial software had to be streamlined and efficient to survive in a competitive market. The physical infrastructure was entirely neglected. Retail shelves often sat full of state-produced calculators gathering dust because the country lacked the basic maintenance networks to repair them or even supply replacement batteries. Without consumer feedback to force reliability and usability, Soviet computers remained frustrating tools that the general public ignored. Beyond the economic failures, there was a systemic ideological barrier. Personal computers place immense computational power directly into the hands of individual users. This diagram maps the political problem. When Soviet scientists proposed a nationwide computer network to share data, state planners crushed the idea. They recognized that allowing citizens to freely connect and exchange information would threaten their centralized control. The Soviet state actively restricted the spread of personal machines. A system built on the monopoly of data cannot survive an environment where that data moves freely. By the 1980s, the West was experiencing a grassroots explosion. Computers were moving onto everyday desks, driven by millions of consumers finding new ways to work and communicate. In the Soviet Union, advanced computing hardware remained securely locked away, reserved strictly for the military and the political elite. The machines that did exist were chronically underutilized. Sergei Lebedev and his fellow scientists possessed the raw intellect to build the future. They proved that in a ruined monastery in 1951, but they were trapped inside a rigid system that refused to adapt. You cannot build an information age inside a system that is terrified of information.
Thank you very much for watching this video. I hope you enjoyed it and learned something from it. Please help the channel out with a like on this video and subscribe if you want to stick around and watch more videos like this. Speaking of more videos, there should be some of them on the screen now. See you in the next video.